In today's lecture, we will look at higher order and mixed partial derivatives. Example 1. Dou square by dou x square of x cube, y cube, z cube. This can be written as dou by dou x of dou by dou x, x cube, y cube, z cube. Dou by dou x of taking the partial derivative with respect to x gives 3x square y cube z cube. Once again, taking the partial derivative gives 6x y cube z cube. Let's cement this idea by looking at another example. Example 2. I want to take double derivative with respect to y. And this time let the function be x cube cos y z cube. This can be written as, since x cube and z cube are to be treated as constant, we can write it as x cube z cube dou square by dou y square cos y. X cube z cube dou by dou y of dou by dou y cos y. X cube z cube dou by dou y. Derivative of cos y is minus sin y. And derivative of sin y is cos y. So therefore, the answer becomes minus x cube z cube cos y. Let's work out another example. Dou square by dou z square x cube cos y z cube. Since x and y are to be treated as constant, I can write this as x cube cos y dou square by dou z square z cube, or x cube cos y dou by dou z of dou by dou z of z cube. Dou by dou z of z cube gives me 3z square. 3x cube cos y dou by dou z of z square. Therefore, the final answer is z square gives me a 2z. 3 times 2 is 6 x cube cos y z. Now, let's look at mixed partial derivatives. This is example 4. Example 4. Let me choose the same function that was used in example 1. X cube, y cube, z cube. Mixed partial derivatives contain derivatives with respect to different variables. Example, dou x, dou y. As before, we write this as dou by dou x of dou by dou y, x cube, y cube, z cube. Notice that both the derivatives do not involve z at all. So therefore, I can safely treat z cube as a constant and write this whole expression as z cube dou by dou x dou by dou y x cube y cube equal to z cube. When you want to take derivative of x cube y cube with respect to y, I can treat x cube as a constant. Therefore, I can write it as dou by dou x x cube dou by dou y of y cube z cube dou by dou x x cube is here. Derivative of y cube is 3y square. Now notice 3y square is to be treated as a constant because now the derivative is being taken with respect to x. So therefore 3y square z cube dou by dou x of x cube. This gives me 9x square y square z cube. Let us look at one more example. Now this time, let's do the following. Dou square dou x dou z. I can write this as x cube y cube z cube dou by dou x dou by dou z of x cube y cube z cube. So a simpler way to interpret this is the result of this is once again taken derivative with respect to this. Therefore, dou by dou x, the result of derivative of this function with respect to z gives me 3x cube y cube z square. Now, this result is taken derivative with respect to x. So therefore, the answer is 9x square y cube z square. Let me conclude this with a higher order mixed partial derivative. We write example 5. This involves double derivative with respect to one variable and also a mixed partial derivatives. So therefore, let's say I want to calculate this dou x dou y square of x cube, y cube and z cube. This can be written as dou by dou x of dou square dou y square x cube, y cube, z cube. Dou by dou x of this gives me 6y square because x cube, z cube can be treated as constant. Let me write one extra step for the sake of clarity. Careful here. Yes. This is z cube here, y cube. Dou by dou x cube, z cube. Double derivative of y cube gives me 6y. Now treat z and y variables as constant. So therefore 6z cube y. Dou by dou x of x cube. This gives me 18x square z cube y. I strongly urge the students to do this particular as homework. Dou cube, dou x, dou z square. Use the same function x, y, z, f of x, y, z, dou cube, dou y, dou z square, f, dou cube, dou z square, dou y, and finally f by dou x, dou z, and dou y.